Hey, welcome. So today, we're going to do something pretty wild. We're going to build a thinking, moving humanoid robot right here from the ground up. We'll be following the exact blueprint that engineers are using right now to bring physical AI to life.
This question used to be pure science fiction, right? But the blueprint is now very, very real. The challenge isn't just about wires and motors. It's about creating an intelligence that can actually perceive, reason, and act in our complex, messy, and unpredictable world.
And that's exactly what we're going to do together. We're going to assemble our robot piece by piece and follow the entire pipeline, from the very first sketch all the way to a fully functional AI. So where do we even begin? Well, we start with the core challenge itself. This isn't about software running on some distant server in the cloud. Nope, this is about code meeting the real world, about intelligence literally getting its hands dirty.
This all comes down to a concept called physical AI. Think of it as the marriage of a physical body and an intelligent mind. Traditional AI lives in the cloud, just processing data. But physical AI, it lives right here with us, navigating our hallways and responding to its surroundings in real time.
All right, let's start building. Every intelligence needs a body to interact with the world. And for our robot, this physical foundation, well, it's everything.
Just building the body is a massive engineering challenge. The design, that's the blueprint for what the robot can even do. The anatomy is how you arrange all the joints and limbs. And locomotion, well, that's the incredibly complex science of just getting it to walk like we do without falling flat on its face.
But look, an amazing mechanical sculpture is kind of useless on its own. How do you tell the hand to grip at the exact same moment the arm lifts and the legs adjust for balance? It needs a nervous system.
And that brings us to the next crucial layer, the robot's nervous system. We absolutely need a way to send signals instantly between every single component, from a tiny fingertip sensor all the way to the powerful motors in its legs.
In the world of robotics, that nervous system is called ROS2. It basically acts as a universal translator and a super high-speed messenger for all the robot's parts. And this is a true game changer because it's a standard. Instead of every company reinventing the wheel, ROS2 provides a common language, letting the robot's eyes, hands, and feet all communicate and act as one single coordinated entity.
Okay, so we have a body. We have a nervous system connecting it all. Now, for the most revolutionary part, the brain. This is where the AI in physical AI truly comes to life. And here's the crucial point. A robot's brain can't just be a calculator. It has to be an interpreter. It doesn't just see pixels, it needs to see a door, understand the concept of a door, and then figure out how to use the handle. That requires a totally different level of intelligence.
This is done through something called vision, language, action models. They are the three pillars of the robot's intelligence, and they work together in this seamless loop. Vision lets it see and interpret the world. Language lets it understand our commands, like, hey, can you please get me that water bottle? And action? Well, action is the magic that connects the two, translating that command into the precise physical movements needed to get the job done.
Okay, but think about this for a second. A toddler learns to walk by falling down. A lot. You really can't have a multi-million-dollar robot learn the same way, right? So how do you teach it all these complex tasks safely? The solution is brilliant, actually. You give it a virtual playground, a digital training ground where it can practice, fail, and learn millions of times over without ever getting a single scratch. This is all done using digital twin simulation. You build a pixel-perfect, physics-accurate copy of the robot and its environment inside a computer. The AI brain is then plugged into this virtual body, and it can run through thousands of scenarios in the time it would take to do just one in the real world. It basically becomes the robot's own personal training dojo.
So, we now have all the pieces: the body, the nervous system, the brain, and the training ground. So let's put them all together and look at the complete blueprint from start to finish.
And here it is, the complete AI robot pipeline. It all flows perfectly in order. First, you design the physical body. Then, step 2, you connect everything with its nervous system, ROS2. Step 3, you install that intelligent brain, the vision language action model. Then, for step 4, you train that brain for thousands of hours in a safe digital twin simulation. And finally, step 5, only when it's ready, you deploy that trained intelligence into the real physical robot.
So the key takeaway here is that this isn't just a random collection of cool technologies. It's a structured, repeatable process. This 5-step pipeline is the fundamental blueprint being used right now to build the next generation of physical AI.
So there you have it, the complete blueprint for a modern humanoid robot. Every major component we talked about is now in place, which leaves us with one final and really fascinating question. Now that we have the blueprint, what will we build next?